Everyone. So in our earlier video we have studied about the intuition of trigonometry, how we get the functions, how they can be plotted on a unit circle, how to understand what are the signs. Like every formula now you can intuitionally understand how it has come, or if you want to understand what are the signs in which quadrant, using the unit circle you will be able to do that. So one thing is the intuition, okay? It helps to remember things better. Like if now you come across any formula, you'll be able to remember it better using intuition. But what happens in general entrance exams is that there are a lot of questions, and each time by using the intuition you cannot derive the formula, right? It will take a lot of your time. But if you have the intuition, you can remember formulas better. So generally what I used to do during my preparation is that every chapter I used to maintain one single sheet. In one single sheet I used to write down all the important formulas which are there. Okay, so it is to help me revise better. Like I did not have to go through all the derivations or all the understandings of the chapter. Just one sheet, all important concepts, all important formulas in that one single side of sheet. If the chapter is long enough, I used to have two sides, front and back. It used to save a lot of time during revision. And if while revising I was not able to understand any particular concept, then I used to have a relook at the derivation of it and I used to try to understand it again. So yeah, for the scope of this video, let's try to go over trigonometry formulas. So this sheet I have taken from a reference link over the internet. I will add it in the description of the video. Okay. So one thing that we know is this is a right angle triangle, opposite, adjacent, hypotenuse. So this is the angle, right? So our entire frame is in frame of this angle. So this is the adjacent, this is the opposite, this is the hypotenuse. So yes, so we know these formulas that sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, tan is sine upon cos, that is opposite upon adjacent. These are the inverse formulas of each of these respectively, right? We know this, but this helps to quickly revise all the formulas. Then if we know the angle sine theta is equal to y, we wrote no right, any point on the unit circle is cos theta comma sine theta, right? Cos theta is x, y is sine theta. So x is cos theta, y is sine theta, y by x is tan theta, right? Cosec is 1 by y, 1 by x by y. Opposite of this, right? So now we know unit circle, we know the point on unit circle, we know how this coordinate is represented in terms of unit circle. What are domains? So sine theta, here theta is in radian. So theta can be anything from minus infinity to plus infinity. Cos theta. Theta can be anything from minus infinity to cos infinity, right? We know that the circle keeps going 2 pi, 4 pi, 6 pi, right? Tan theta. Now tan theta, here theta cannot be n plus 1 pi by 2. Why? So what is theta? Theta is sine theta upon cos theta, right? So here cos theta should not be 0. Where is cos theta 0? At this, right? At these 2 points cos theta is 0, right? Because x-axis is 0 here. All points are here on y-axis. So theta cannot be n plus 1 pi by 2. So using the unit circle, we are able to understand the ranges where theta can lie, right? This cosec theta is what? Cosec theta is 1 by sine. So sine theta, where is sine theta 0? Sine theta is the y, right? Is the y point. So y point is 0 here. So x-axis. So n pi, this is 0, 2 pi, this is pi. So all n pi. It cannot be n pi. Sec is 1 by cos. Cos cannot be 0 here. What is cot? Cot is cos by sine. So where sine cannot be 0? Sine cannot be, where is sine 0? Sine is 0 on this axis, so it cannot be n pi, right? So using the unit circle, we are able to understand the ranges of it. So that will help us to remember things better. What are the ranges of trigonometric functions? Sine theta is minus 1 to plus 1. You know, right? This is a unit circle. It goes from minus 1 to plus 1 only. So cos theta, sin theta are the points, so it will be from minus 1 to plus 1. What is tan theta? Minus infinity plus infinity. How is that possible? Sin theta upon cos theta. So cos theta can come near to 0, right? So as cos theta comes near to 0, this value will keep on increasing, right? it will keep, as it comes near to 0, this value will keep decreasing and this value will keep increasing. So it is possible to reach negative infinity to positive infinity. You're able to get the intuition, right? This is the opposite. Cosec is 1 by sine, sec is this, so it has to be between 1, it has to be greater than 1 or less than -1. Sec same thing, cot also same thing. These are our formulas. We know tan is sine by cos, cot is cos by sine. Reciprocal identities, we know this. Pythagoras, these are very important. This is a right angle triangle, right? Sine square plus cos square is equal to 1, tan square plus 1 is equal to sec square, 1 plus cot square is equal to cosec square. These formulas we must remember. These can be derived using the right angle, right? Now even and odd we discussed yesterday. Now if suppose there is a minus theta angle here, what is this point? This point is negative y, positive x, right? Negative y is sine minus, right? Minus sine theta. Cos theta is plus, minus tan theta, because sine is very negative. Minus cosec plus sec minus cot. Using the unit circle, we are able to understand what point will lie into which quadrant. Understand this. This is minus theta. This will be what? This is negative. This is positive, right? It is positive, negative. So cos is positive, sine is negative. If n is an integer, theta plus 2n pi is sin theta, theta plus 2n 2 pi n is cos theta, right? These will be able to understand using this unit circle. What is double angle formulas? Double angle formulas can be derived. I will run through the derivation in some other video, but for now try to remember this. Then degree to pi we have already seen in the previous video. So if t is the angle in radian, it is pi by 180 into x, and x is degrees, then 180 by pi into radian. So this is very important. Degrees to radian, radian to degrees. These are the half angle formulas. You should know the half angle formula. So many of the times if there is some big equation, you might have to put sin theta in terms of their double angles. Sum and difference formulas, these are also very important. What are product to sum formulas? Now try to understand this. This is sum to product, this is product to sum. Sum to product formulas again. These are the complementary formulas. Sin pi by 2 is pi by 2 minus theta is cos theta, cosec pi by 2 minus theta is sec theta, tan pi by 2 minus theta is cot theta. So these are complementary angles. Same way here, these are complementary angles. So it's very important to get an intuition. So where these type of formulas can come, right? Sin 60 plus 30. So if sin 90 is given, you should be able to split it as 60 plus 30. Although this is not the right example, but this is where these formulas come into place. This is the unit circle. So unit circle is very important to get the intuition of the entire trigonometry. So any point here, we know the angle, we know the coordinate, that is cos theta, comma sin theta, right? So just have a look through this sheet, and any questions, doubt, you all can come back. But I think this sheet is good enough to summarize the entire chapter. And you have to, in trigonometry, the trick is you should be able to apply the formulas right time. This sum difference, product to sum to product are very important, and you should get an intuition. Okay, this question, this is the formula to be used. With practice, you will be able to develop the intuition for it. Yeah. If you are like this concept and this video, please like and subscribe. Looking forward to the next video. Yeah.